astronomers have discovered the second closest black hole to Earth, Gaia BH3, but this black hole is very, very different from anything we discovered so far. First of all, it's almost 3.5 times larger than the closest black hole yet discovered, putting it in the category of black holes that shouldn't exist. At least, within what we initially knew about these particular black holes. There's just one question on my mind. If such a gigantic black hole is right under our noses, and we have missed it for all these years, what other black holes do you think are out there right now that we don't know about? Let's find out. First of all, it was not NASA that made this amazing discovery, but the Gaia Space Observatory sent by the European Space Agency ESA in 2013. Gaia, like the famous James Webb Space Telescope, LI orbits around a special gravitational region we call the Lagrange point. This is due to the interaction of the gravitational fields of the Sun and the Earth. One of 5 special gravitational regions, the LI point around which Gaia orbits is located on an imaginary line connecting the Sun and the Earth, on the side of the Earth that is away from the Sun. About 1.5 million kilometers away, Gaia has achieved incredible success since its inception. For example, out of the 400 billion stars in the Milky Way galaxy, we have seen 1.7 billion of them to date. Thanks to Gaia, we have been able to catalogue with high precision and discover a whole new world of exoplanets and galaxies every year. We continue to discover stars. Instead of publishing all this data about celestial bodies one by one, astronomers generally prefer to compile all new findings into a catalogue and publish them every 3 or 4 years. For example, Gaia's latest data catalogue was published in 2022, and the next one will be published in 2025. But the discovery of the Gaia BH3 black hole is so important that astronomers chose to publish an article dedicated to it without waiting for the new edition of the catalogue, because work on this black hole needs to start immediately. Even though Gaia BH3 is of an extraordinary size, it is actually among the smallest black holes we have discovered to date. Because it is not a supermassive black hole, it is a stellar black hole. But here it is in this category. It has a mass much larger than we have ever seen, and this makes it very special. As I have explained to you before, when stars 8 times or more massive than our Sun reach the end of their lives and run out of fuel, they explode in a tremendous explosion we call supernova. During this explosion, they disperse most of the matter and energy that comprise them into space. The remaining material is compressed with such force during this explosion that an enormous amount of matter accumulates in a tiny volume. If the amount of leftover matter is above the 2 to 3 solar masses known as the Tolman-Oppenheimer-Volkow limit, the remaining stellar core continues to collapse in on itself, turning into the most mysterious object in the universe, a black hole. If it is below this limit, then a neutron star is formed. But here's something that fewer people know. There is a minimum mass for a star to become a black hole, as well as a maximum mass. Because if the dying star is abnormally large, then some processes that occur more weakly in smaller stars occur much more violently, preventing the star from turning into a black hole. For example, if the star is very large and has a high metallicity, that is to say if it contains a lot of atoms heavier than hydrogen and helium, very strong stellar winds are formed around this star. These winds cause the gases in the star's upper atmospheres to be dispersed into space at high speeds. Yes, stars, like planets, have atmospheres, and the activity there can determine the fate of a star, just like the Earth's atmosphere can determine the fate of the Earth. In addition, some other factors, such as extremely high energy rays produced by extremely large stars, currents caused by temperatures reaching millions of degrees in the corona of stars, and resulting from the movement of the star's magnetic fields due to events such as coronal mass ejections that we are familiar with from the explosions on our Sun, these winds can reach speeds of hundreds, even thousands of kilometers per second, allowing atoms in a star's atmosphere to escape its gravitational pull and be blown off into space. Here are very large stars. Because they lose too much mass in these ways, especially towards the end of their lives, they cannot experience supernovas that would form very large black holes after their deaths. In addition, an extra special event called a pair instability supernova can occur in stars that are 100 to 250 times more massive than the Sun. Since the cores of these extremely large stars are extremely hot and extremely high pressure, thermal photons in the stellar core can spontaneously generate electrons under those conditions. They begin to create positron pairs. These pairs steal the energy of the photons that prevent the star's core from collapsing in on itself, causing them to weaken and the core to become increasingly unstable. Supernovas that occur in massive stars with a weakened core are so devastating that nothing is left of the star that could create a black hole. All the material is blown into space. For all these reasons, this special group of black holes, which are formed by the death of stars and therefore called stellar black holes, has been known for a long time. We thought it might be around 20 solar masses at most. A larger stellar landmass than this should not be possible. Let me remind you, the newly discovered Gaia BH3 far beyond this limit. And that's why I mentioned it as a black hole that shouldn't exist in the first place. This is the first thing we discovered, though, nor is it a stellar black hole of abnormal size. If you recall, the biggest science news of the year 2015 was the LIGO interferometer, which was the result of the merger of two black holes. Was the detection of gravitational waves radiating into space, and that discovery is indeed another of the most amazing predictions of Einstein's theory of general relativity. An important detail that was not emphasized or understood enough in these reports was that one of the merging black holes had a mass of 29 solar masses and the other had a mass of 36 solar masses. If you notice, both of these, beyond the 20 solar mass upper limit, we predict for stellar black holes. Although there were previously signs that this could happen at 21 solar mass. We had already discovered Cygnus Xi. But it did not pose a serious problem for the theory at hand, since it did not push the 20 Sun limit far enough. LIGO's findings in 2015 indicate that there is something else at work. Showed it to us clearly for the first time. It is crucial that we figure out exactly how these stellar black holes form. Because like Gargantua in Interstellar, or if I were to give a real-world example, we know very, very little about how supermassive black holes, which are found at the center of almost every galaxy, such as the Sagittarius A star at the center of our Milky Way galaxy, were formed. These are not just 20 or 30 times larger than the Sun, but gigantic black holes that can be 4 million times larger in the case of the Sagittarius A star and billions of times larger in other examples. Most likely these are absurdly large stars that are poor in metal and therefore not very affected by stellar winds, without even being able to go supernova. They start their lives in giant sizes by collapsing directly onto themselves, and over the next billions of years they merge with other black holes. They also reach abnormal sizes by swallowing the material around them. But research on this subject is still ongoing. But our focus today, Gaia Black Hole 3, or simply Gaia BH3, is at least as interesting and surprising, even if it is not a supermassive black hole. Because this stellar black hole, which is almost 33 times larger than the Sun, is only 1930 light-years away from us, and we are so close to it on the astronomical scale. We are just now discovering such a massive black hole. Now let me say this clearly. Of course, 1930 light-years is still a tremendous distance. It is 2% of the distance from one end of the timeline galaxy to the other. Therefore, the probability of us waking up one morning and coming face to face with this black hole is almost zero. Even if we were traveling towards each other at the speed of light, which we are not, we would only reach the same point as it in about 1,000 years. Think about it that way. But when we talk about risks on an astronomical scale, we are never talking about events that will happen in 3 or 5 days or, I don't know, 3,000 5,000 kilometers away. That needs to be understood too. But yes, its astronomical value aside, Gaia BH3 is not a risk element to be taken into consideration compared to other risks in our lives. In fact, Gaia BHI, which is 9.5 times larger than the Sun, and was discovered by the same Gaia spacecraft, is only 1,560 light-years away from us. Still, I would say don't underestimate these distances too much, because even if there's BHI in between, BH3, the second closest black hole we've discovered so far, in this region that can be considered the backyard of our home in the galaxy. What other black holes are there that we've missed? Who knows? More importantly, thanks to the discovery of absurd black holes like Gaia BH3, we now have a better understanding of the conditions under which stars much larger than 20 solar masses can turn into stellar black holes. For example, one of the factors that enables this is that stellar metallism, or the ratio of the presence of atoms heavier than hydrogen and helium that I just mentioned. The lower this ratio, in other words, the poorer the star is in metals, the less it is affected by stellar winds. Likewise, the interactions of stars with other stars before their death can also affect the characteristics of the black hole that will form. Sometimes, one of the stars in binary star systems rips off the outer layers of the other. It can cause even stars that would otherwise not be able to form a stellar black hole to shrink to the size they need to form a black hole. And Gaia BHI is indeed a binary system. One of the objects, this is a black hole, the other is a very large, very bright star known as a red giant, and coincidentally, also very poor in metals. In fact, this companion is what made it possible for us to detect BHI. Black holes are space holes that emit no light except perhaps Hawking radiation. They are almost invisible to us in the pitch-black void. So to detect them, we look for anomalies in the orbits of bright stars nearby. If there is something that the star is orbiting around, but we cannot see that thing, this tells us that there may be a black hole there. Then, if we look at the deviations in the course of that star, we can calculate how large an object should be there. And then we focus our observation instrument on that spot, and detect optical illusions like gravitational lensing, and that's how we see that there really is. We can confirm that it is a black hole. For example, the star orbiting BHI revolves around the black hole every 11.6 years. Interestingly, the chemical concentration, it does not appear to be contaminated by material ejected during a recent supernova. Also around Gaia BH3, no accretion disk or accumulation of material that the square hole is preparing to swallow is visible. That's why we were able to detect it so late. But all of this shows us that Gaia BHI formed long before it trapped that star in its own orbit. One day, it will perhaps swallow its companion as well, but this is what makes the discovery even more interesting, because the star orbiting Gaia BHI is itself a star that formed at most 2 billion years after the Big Bang. Therefore, Gaia BH3 must have formed at an even earlier stage than that. Although our Milky Way galaxy formed only a few 100 million years after the Big Bang, it wouldn't be wrong to say that this black hole saw our galaxy in its infancy. Although things take a literally unexpected turn here again. Because the star in the BH3 system, it rotates in the opposite direction to most stars in the central disk of the Milky Way galaxy. When we combine this ancient age with this reverse direction, we conclude that this binary system probably did not form within the Milky Way galaxy. In other words, the second closest black hole we've discovered so far is an alien on a galactic scale. In other words, it's very likely a traveler from another galaxy to us. Which isn't all that surprising, because we already know that our galaxy has collided with many neighboring galaxies throughout its history. For example, between 11 and 8 billion years ago, at least 3.5 billion years before the birth of our Sun, an event humorously called the Gaia Sausage Merger took place. And a dwarf galaxy known as the Gaia Sausage collided with our then-infancy Milky Way, causing countless stars to join us. By the way, The reason why that galaxy is called the Gaia sausage is that it was also detected by the Gaia mission, and more importantly, the speed graphs of the stars that we think are carried with that galaxy are similar to sausages, having a long distribution. Scientists are truly amazing at naming. Anyway, the result is that this mysterious black hole is in our galaxy. It may have been carried away by that collision and accidentally settled into an orbit relatively close to ours. That's it. What we know about Gaia BH3 is still very new, and thanks to the dedicated efforts of astronomers, we will learn much more about it in the coming years. Oh, by the way, first of all, I wasn't actually exaggerating when I said who knows what other black holes there are out there that we don't know about. We think there are over 100 million black holes in the Milky Way galaxy alone, and we have not been able to discover practically any of them. If we want to make sure our solar system stays stable for many more years to come, we need to start finding nearby land as soon as possible. Oh, speaking of the solar system and stability, I think it's time to discuss the three-body problem. If you don't want to miss that video, don't forget to turn on channel notifications now. Also, if you like this video, I recommend you watch this video to learn 10 things you don't know about black holes. See you in the next video. Goodbye. Subtitles by MK.